Another session of probability. This is part 4. In the previous video, we have seen the fundamental counting principle and we did few good questions. Now in this video we go a little further on the fundamental counting principle with new ideas and new questions. Listen very carefully and learn the methods. Arrangements of objects in a row. Question A. In how many ways can 3 boys and 2 girls sit in a row? 3 boys and 2 girls. So total 5 people. We know the method by now. Using counting principle, it is equal to 5 times 4 times 3 times 2 times 1 or equal to 5 factorial, that is 120 ways. Question B. In how many ways can they sit in a row if a boy and his girlfriend must sit together? That is our new question. We have to learn the method. A very simple method. We combine the boy and his girlfriend as one object. And the remaining 2 boys and 1 girl, another 3 objects. So total we have 4 objects now. Learn the method. 4 objects. How many ways we can arrange them? We can arrange them in 4 factorial ways. Again, the boy and girlfriend, although they are together, they can sit as B, then G, or G, then B. Okay? That itself, that is 2 factorial ways. So the total number of ways, according to the fundamental principle, the answer is 4 factorial times 2 factorial. That is the method of sitting together, arranging together like questions. Final answer is 48 ways. Question C. In how many ways can they sit in a row if the boys and girls are each to sit together? Boys together, girls together. So we make use of the idea of making objects. So we have 2 objects now here. Boys together make 1 object and the girls together make another object. 2 objects. How many ways? It will be 2 factorial ways. Again, the boys, 3 boys can sit in 3 factorial ways and the 2 girls can sit in 2 factorial ways. So the final answer, they can together sit 2 factorial times 3 factorial times 2 factorial. That is 24 ways. Question D. In how many ways can they sit in a row if just the girls are to sit together? So we are learning a beautiful method here in this video. Try to understand and try to master it. So girls together, that is an object, and the remaining boys, 3 objects, making 4 objects. Now that is 3 factorial, 4 factorial, 3 objects and boys 3 objects and girls 1 object, making 4 objects in 4 factorial ways. Also the girls, 2 girls in 2 factorial ways So what is our final answer? 4 factorial times 2 factorial, which is 48 ways. Another question. A group of 3 South Africans, 2 Australians and 2 Englishmen are staying at the same hotel while on holiday. Each person has his or her own room, and the rooms are next to each other in a straight corridor. If the rooms are allocated at random, determine the number of ways that the 2 Australians will have adjacent rooms, and the 2 Englishmen will also have adjacent rooms. They are not staying together, but they have adjacent rooms. So, how many people we have? We have 2 Australians making one object, 2 Englishmen making one object, the remaining South Africans, 3 South Africans, 3 objects, total 5 objects. What is the answer? 5 factorial. Again, the Australians, 2 Australians in 2 factorial ways and 2 Englishmen in 2 factorial ways. Therefore, together, all of them together, we have the answer 5 factorial times 2 factorial times 2 factorial, which is equal to 480 ways. Good people, these are beautiful questions. I think you have mastered the method by now. In how many ways can 4 mathematics books, 3 history books, 3 science books and 2 biology books, question A, be arranged on a shelf in any arrangement? How many books total we have? We have 12 books in 12 factorial ways. On the calculator, look at the answer on the calculator. It's a very big number. Question B, be arranged on a shelf so that all the books of the same subject are together. Meaning mathematics books together, history books together, like that. Now we make use of our method of objects. Here is how many objects we have. We have 4 objects in 4 factorial ways. Then 4 maths, making another 4 factorial ways. 3 history, 3 factorial. 3 science book in 3 factorial. And 2 biology books in 2 factorial. So the product of these numbers will give us the number of ways, 41,472 ways. Now we move on to another type of question. Letter arrangements where letters are repeated. Okay, so you are going to get questions of these arrangements in the probability. Consider the letters of the word mathematics. Question A, how many word arrangements can be made with this word if the repeated letters are treated as different letters? Although you have repeating letters there, but they are all considered as separate. How many letters in total? We have 11 letters. And the answer is 11 factorial. Question B, how many word arrangements can be made with this word if the repeated letters are treated as identical, meaning same? Identical means same. So what is the method of calculating the number of arrangements? Listen very carefully. The idea is very, very interesting. We have 2 M's, 2 A's and 2 T's. Okay. Then what we have to do is you divide. We have that the total number of ways 11 factorial from the previous question. You divide that number by 2 factorial times 2 factorial times 2 factorial. That is the answer, and calculator gives us a very big number of arrangements. Consider the letters of the word needed. Okay. Question A, how many word arrangements can be made? The repeated letters are treated as different letters. So we know that there are 6 letters, 6 factorial. So the answer is 720. Number B, the repeated letters are treated as identical. So we have 3 E's, 2 D's, and we divide by 3 factorial times 2 factorial. Remember to write times there. Equal to 60 arrangements. Number C, how many word arrangements can be made with this word if the word starts and ends with the same letter? Starting and ending, we have 2 options here. Look at this. Starting with D, ending with D. Second option, starting with E, ending with E. Now, we calculate. The 2 D's are already fixed. Remaining 4 letters in between. We can play around those 4 letters in 4 factorial ways. So, again we look at the 4 letters. There are 3 E's. Then we divide by 3 factorial, giving us 4 arrangements. Second option, we have 2 E's already fixed. In between we have 4 letters, but there are 2 D's. Then we divide by 2 factorial. So the total number of possible arrangements, you add 4 and 12. 4 plus 12 equal to 60. Consider the word winning. How many word arrangements can be made if the word starts with the letter I? So I is fixed. Remaining how many letters? We have 6 letters. Out of the 6 letters, there are 3 N's. So we divide by 3 factorial. We get the answer. How many word arrangements can be made with this word if the word ends with the letter N? Okay. N is fixed. Remaining 6 letters in 6 factorial. But we have 2 N's there. So we divide by 2 factorial. Okay. 6 factorial divided by 2 factorial. And also we have 2 I's. So another 2 factorial there. We get the answer. 2 N's and 2 I's. Okay. Now example involving probability. We are going to calculate the probability. Consider the word dreams. If the letters are arranged in any order without a repetition to form different words, what is the probability that the word will start with D and end with S? So we know by now D is fixed, S is fixed. In between we have 4 letters. So we can play around only 4 letters. Okay. So we get the total arrangement is 6 factorial. We are calculating the probability in this question. Remember that. And the favorable outcome. Okay. D and S fixed. Then remaining 4 letters, 4 factorial. That is the favorable outcome. And what is the definition of probability? Learn from this example. Favorable outcomes divided by total outcomes, which gives us 4 factorial over 6 factorial. That is 1 over 30. That is the method. Good people, we end the probability videos here. Share the video to your friends so that all of them will learn the method. Good luck Thank you.